he's becoming quite a hard act to follow these days, actually. I think he's going to put me out of a job with all his lineup of jokes. How many mathematicians do we have in the room, just to give me a sense of who I'm talking to? Okay, great. So the mathematicians in the room, you probably have the similar experience that I do when I go to parties, and you get this question about what you do. I don't know, perhaps you all fake it. I'm starting to fake it, actually, and say I'm an international spy or something. But because most of the time, I get a kind of stock set of reactions. One of them is that they just flee to the other end of the party, and I'm abandoned. But actually, always before they go, they always tell me what they got in their GCSE or O-level, which is, I'm not really quite sure what that's about. But if they do stick around, one of the things they often say is, he's trying to work out the tech here, which is, doing a talk about tech is always a disaster, actually using the tech. But so one of the questions I often get, or statements, is that, come on, surely you must have been put out of a job by a computer by now. I think it's mostly because people think that what I do in my office up here is long division to lots of decimal places, and if that were true, certainly my computer would have put me out of a job. But you know, we're all, as Alan said, we're all a little bit threatened at the moment about this advancing AI that it seems to be very powerful, doing lots of interesting things, and surely aren't computers all about kind of logic and mathematics? So wouldn't my job be one of the first to be threatened? I got this a lot during the 90s, actually, when Deep Blue beat Kasparov, because often people used to compare the idea of playing a game of chess to doing mathematics. There are certain logical moves you can make with the pieces. There's a kind of end game that you're after, the end of the proof, the QED, where you sort of win the game or you win the proof. And so a lot of people said to me during the 90s, well, come on, you must be next. But I never felt particularly threatened by chess. And actually, there was always another game that we mathematicians always used as our kind of protective shield against the idea that computers could do our subject. Because there's another game, and that's the ancient game of Go. This Chinese game played on a 19 by 19 grid where you put black and white stones down, you try to engulf the other person's territory before they engulf yours. And this is a game which has a high degree of complexity, much more complex actually than chess. There's a lot of pattern recognition that needs to go on to be able to play this game. And that's something that really mathematics is about. It's about spotting patterns, underlying patterns. But quite often when you're playing Go, and especially when you're doing mathematics, to be able to quite know where you're going requires a lot of intuition, a lot of creativity, not quite sure why you're making moves. You spend a lot of time in this world and you build up kind of a feel for playing Go or doing chess. And very traditionally in computer science lectures, they would always say, yeah, chess is something we can automate because we can understand the kind of logical implications of playing particular moves. We can follow the tree of possibilities through. Go was always said to be a game that no computer would ever be able to play. And certainly any attempt of somebody trying to encode the way that a human plays this game always failed. The attempts to try and encode playing Go in some sort of algorithm wouldn't even beat an amateur at this game. So I felt pretty safe because computer science say you can't play Go, so you certainly won't be able to play the complex game of mathematics. So I got a little bit of a shock a couple of years ago, and you're probably aware of this story, when a team in London declared that they had got an algorithm that they believed could compete at not just a high level, but the highest level. This is DeepMind in London, and actually it was Demis Hassabis who went to he went to Cambridge to do his study, and he was told this old adage that you can't program a computer to play Go, and this was like a red rag to Demis, and so he went away and set up this company, and they devised this algorithm that they thought could play the best, and they challenged Lee Sedol, a Korean grandmaster, and Lee Sedol was totally dismissive of this algorithm, that it wouldn't be able to get anywhere near the level that he could play at. He said, I'm going to demolish this thing 5-0. They were going to play over 5 games. But he got a little bit of a shock. I sat and watched these games obsessively on YouTube because I realized that my life was probably under threat. And as I watched, I saw Lee Sedol get more and more depressed throughout the games. He lost the first game, he lost the second, he lost the third, he'd lost the match already after 3. He won the 4th game, and he now regards that as the greatest game that he's ever played, that he was able to beat this algorithm in 1 game, and he lost the 5th game. So he lost 4-1. What had changed in the last few years? The style of coding has changed, and we've got new sort of code on the block which is able to do things that code in the past couldn't do. And it's something that we're very interested here in Oxford, this idea of deep learning or machine learning. So code in the past used to be written in a very top-down manner. You really had to know what the thing how the thing was going to behave. You told it the rules of how it was going to play. You had to understand the setting, and the machine just implemented that. Yeah, sure, it could play chess because it was told to implement this thing. It could go deeper. It could analyze more situations than a human. But the human was still telling the program what to do. What has changed is that the code is now written in a very bottom-up manner. We've got a sort of code which is learning very much like a child learns. In the past, it was like the parent's DNA would give birth to a child, but the child would be still attached to the DNA of the parent. It wouldn't learn anything new. But suddenly we've got code that can adapt and change and mutate and reparameterize itself as it encounters a new environment. There's almost like a metacode which is telling the code how to change if it gets something wrong and change and mutate. And this is what they use to actually train AlphaGo, to learn how to play this game by playing games and failing. In fact, they started with some other games to start with, some simpler games. So, in fact, they started with Atari games I used to be obsessed with, actually, when I was a kid. And one of the ones I really loved was this one called Breakout, where you have a ball which ping-pongs up and down, and you've got a paddle, and you've got to knock these out, and you score points. The blue are just 1 point, up to red, the higher points. The machine was only given the pixels on the screen and the score. It had to learn how to play this game. It wasn't told anything about the fact that you had to hit this ball, but it was randomly moving the paddle, and every time it hit the ball, it saw the score go up. So it parameterized itself and said, I'm going to prioritize moving towards where the ball came from. Now, when I was with my mate and we played this, we were very pleased when we found a fantastic hack, because you can create a little tunnel on the left-hand side, and then if you get the ball to go up there, then you don't have to do any work at all because the ball just bounces backwards and forwards. What I was absolutely staggered when you see how this DeepMind actually learned to play the Atari game, it learned the same hack. It is, not just humans, but the computer is also lazy, doesn't want to move this thing around, so shoots it back up again. This is extraordinary. After 600 games, it had learned just by randomly moving the paddle and seeing that what the moves were that made the score go up fast, it had learned how to do this hack. So this is how it then went on to play the game of Go. So what it did was to first take all the human games that are on the internet. A lot of games encoded on the internet. It learnt how humans lost and won the games. And that was its first material that it learnt on. Then it started to create synthetic data. It started to play itself. Different versions of itself would play a game, and then if it lost a game, it would understand which were the moves that meant that, that it actually was failing to play at a high level, and it would reparameterize itself. And so after a while, it got to this high level, quite amazing that it did, such that it could challenge Lee Sedol. Now, at first sight, you say, okay, so the computer's just got very good, it can analyze its game very deeply, but I think that there was something more amazing that happened during these games. The first game, interestingly, Lee Sedol decided that if it had done learning on how humans played, maybe the best way to beat this computer was to play rather unlike a human. So he actually played a very disruptive game, but the AlphaGo was smart enough to actually just cope with the moves that he was making, and they turned out to be quite weak moves, and he lost the game because he was not playing his standard game. So in the second game, Lee Sedol decided to play a much more standard, high-level game that he knew very well. Very early on in the game, your Go master teaches you a few things, strategies. One is that you should play on the kind of edge of the board. So you're encouraged to play on the first, second, third, and fourth rows in, because there's a kind of competition early on for the edges and the kind of internal part of the board. And if you play too far into the middle of the board early on, it's considered a weak move because you're not really establishing important territory at that point. So Lee Sedol, on the 36th move of this game, decided that he needed a cigarette break, and he went up to the top of the hotel, had a cigarette. AlphaGo didn't need to smoke in order to get stimulation, so it sat there and it thought for a while, and then it asked the human player, because this wasn't an exercise in robotics, this was an exercise in just pure thought, so there was still a human. This is actually still quite difficult for an AI to actually pick a stone up and place it on the board, but it told the human player to place a stone on the 5th row in. So I've circled this. He was playing, I already anthropomorphized the AI. The AI is playing black, and it put this stone in on the 5th row in, which I put a little white circle on. All the commentators, I remember this on YouTube, they all gasped and went, whoa, wow, AlphaGo's made a huge mistake. You never play that sort of move early on in the game. This is Lee Sedol will be in, it'll be 1-1 after this. And they were all very complacent. And Lee Sedol came down after his cigarette break, looked at what AlphaGo, and you can see, you should watch this back, it's so funny, because it just, Lee Sedol, like, cannot believe what this AI has just suggested. What a stupid move. But he's a bit more suspicious and thinks, you know, why has he done that move? Well, I still say, why did it do that move? It turned out that as the game built up, and there's something rather different about chess and Go, because chess gets simpler as the game goes on, because pieces get taken off. But Go gets more and more complex because more and more pieces get put on. As the game built up and more pieces were put on the board, territory was building up from the bottom right-hand corner. And it turned out that AlphaGo's move, at move 37, that black stone meant that it was it that won that territory rather than Lee Sedol. It was an incredibly inspired move. It won AlphaGo the second match. That decision on move 37 to put the stone there and break the tradition of how humans thought we should play the game. And for me, this was really exciting because I believe that this is an example of what we should call a creative act by artificial intelligence. I spent some time on a committee at the Royal Society over the last few years. We've been looking at the impact that machine learning is having on society over the next kind of 10 years. Demis was on the committee, and there was also a philosopher, Margaret Bowden, and I talked to her quite a bit about the idea of creativity. She's been very interested in what she calls these tin cans can do, computers, and the idea of whether they could be creative. And she had a very nice working definition of what we should call creative. I'm not sure it's the best one, and we can argue there's lots of philosophical debate over the idea of what we mean by creativity, but I think this is going to be quite a useful working definition as we go forward tonight. So creativity is something which should be new. Well, computers can make new things quite easily. We can objectively judge whether something is new, but it should have two other qualities. It should also have an element of surprise. Now that's a little bit more subjective, and also value. That's also quite subjective. So a computer, if it's going to be creative as something that we as humans believe is creative, it's going to learn to know what we think is surprising and has value. What I think is so nice about games is, of course, you can judge this kind of these qualities quite quickly. Surprise, yes, the commentators all went, oh, it's made a mistake. Value, yes, this move won AlphaGo the game. And so what I've been interested in is to look at, if it can be creative in this very closed environment of a game, where else can it be creative? Can it be creative in mathematics? Actually, I sat next to Demis and I joked to him, we'd just become both FRSs. And I said, oh, could you get AlphaGo to become an FRS? And part of the story of my book is about, Demis said, yeah, we're already on the case. So they're already a deep mind looking at making a creative AI mathematician. So the journey, what I think is exciting about this kind of new AI that is appearing is that in the case of AlphaGo, it not only played the game at a high level, but it taught us how to play the game in a new way. We thought we'd reached a kind of peak of playing with these kind of rules that we had about playing in the 1 to 4th row in, and there was a kind of optimal way to play the game. What AlphaGo has shown us in these games is that although we thought we were at the peak of performance in playing this game, actually this was only what we mathematicians call a local maximum. Actually, this was like Snowdonia, and there was actually a much higher mountain, an Everest, a new way to play the game. That AlphaGo had experimented by taking risks, gone down this kind of adaptive valley, and found a much better way to play. And AlphaGo has now taught us a new way to play this game, new strategies that are helping us to play the game at a much higher level. And so the journey of this book, which is called The Creativity Code, is to look at, well, this AI that is appearing that seems to be able to learn about, through its interaction with the kind of digital world around it, could it perhaps be creative in other realms, not just creative in a game? In fact, one of the first people to think of the idea of code was already suggesting that code might be able to do things of an artistic nature. So we celebrate Ada Lovelace Day. Ada Lovelace every year. Ada Lovelace was taken by her mother to see Babbage's analytic engine. Her mother used to like to expose her to lots of different ideas, scientific ideas. And when she saw this machine, she already began to realize that this could do more than just the long division or the multiplication, that it could do something a little bit more exciting. And she started to write down code to make the analytic engine do interesting things. And that's why we sort of celebrate Ada Lovelace. The notes that she wrote for a paper about the analytic engine, we regard as the first idea of code to make machines do interesting things. Already then, she was thinking about the fact that this could do maybe things which are a little bit more interesting than just sort of scientific calculations. And she wrote, the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. So she was already thinking about music, a place, of course, which has quite a lot of connection with mathematics, the idea of patterns, getting the machine to kind of run out patterns. Perhaps it could make music, and we'll come to that a little bit later on, the challenge of whether AI can write music. But she offered a word of caution when she wrote this. She said, it is desirable to guard against the possibility of exaggerated ideas that might arise as to the powers of the analytic engine. It has no pretensions whatever to originate anything. It can do whatever we order it to perform. And I think that's what we always felt in the past, is that this kind of top-down coding, well, it's the human that's telling the computer what to do. So if the computer is being creative, that's because the human has been created and it has encoded that in just a set of rules that the computer is just implementing. But I think something has changed. Now the code is beginning to change, mutate as it interacts with, say, our new artistic data, music, that it's starting to become code that the original coder doesn't quite know how it's performing. So this machine learning is producing programs which now perhaps disconnect itself from the original coder. So here's the challenge. Can this new AI that's appearing, which seems to be moving on from the original code written by the coder, kind of put some distance between the code and the coder? So you've probably heard of the Turing test. Can a computer pass itself off in an interaction online, as Alan did? Would you be convinced that that was a human talking, or is it just an AI computer? So Turing put this down as quite a big challenge. Can it process natural language and respond real time? So here's a new challenge that has been offered connected to the artistic realm. It's called the Lovelace test. So the test is, can a machine originate a creative work of art such that the process is repeatable? So it shouldn't just be some sort of glitch in the hardware. Somehow the code should know what it's doing. It shouldn't be some sort of randomness which is put in there such that the code wouldn't be able to reproduce what it's done. But here's the challenge. Yet the programmer, the person who wrote the code that has now learned and mutated, is unable to explain actually how the algorithm produced its output. So this is the challenge that I want to explore with you. How good has AI been in the last couple of years, and it's really the story of the book, in understanding what we regard as art and creativity and being able to produce its own version of that? And I think I think we're quite happy that AI is going to be driving our cars or maybe even be our doctors, although we're a little nervous of that. If it suggests move 37 in the game 2 of Go and suggests you take a pill that looks incredibly dangerous, do you do that? Is it a mistake or is it an incredibly insightful move that's going to save your life? So I think we're quite happy in certain realms, but I think the one thing that we regard as uniquely human is our own creativity, our artistic output. That's what it means to be human. We express it in music, in art, in poetry and novels. So if AI can get close to doing something that we regard as uniquely human, I think this is a very exciting moment. So how good is it? Well, I think I made a program for the BBC, a Horizon, of about 6 years ago. It was a touring anniversary about AI. And 6 years ago, I was pretty disappointed in the state of AI at that point. And there was one hurdle that AI seemed to be finding really difficult to achieve, and that was vision recognition. Our brain is very good at taking in a huge onslaught of information. Lots of different colors here, people, faces, but I'm able to integrate this into a single story about seeing an audience that's come to the talk I'm giving. So vision was one of the great hurdles for AI at the time. And this is one of the things that it's been able to do with this idea of machine learning. So actually we've used a bit of machine learning to do a few experiments during this lecture. So we have a camera here. So the point is that machine learning, it gets shown some images of cats and dogs and it has to distinguish them and it gets it wrong to start with, but it starts to ask more and more questions which helps it to get it more and more right. So we're going to be doing some tests here. So you'll see you've got some cards in front of you. I'm going to give you some challenges, some AI art kind of Turing tests, Lovelace tests, and you're going to have to decide what you think is made by a human and what do you think doesn't have a soul, and that's an AI. So in order to do this, right, so we're going to get you up on your display 1, and we want the HDMI, so that's interesting. So display 2, I'm going to have, okay, that's interesting. It worked in the rehearsal, exactly. But when you're doing AI and tech, it's always asking for trouble. So, okay, well, do you think you can sort that out?
Possibly not.
It's not a disaster, but okay, so this is how we trained our AI. So what we did was, when you throw up your cards, we want the AI to be able to recognize what you're putting up, that it's a blue, which will be for human, and a red for robot. But it doesn't want to get confused by a red jacket over there or a blue shirt. And so we had to train this AI on pictures. So what we did was we just took a random load of pictures and then we put the things that we were trying to get the AI to recognize. And so there'll be a training image. So we had about 600 training images. And basically, it would be told there are 4 red robots and 3 human faces. And gradually, it learns over those 600 faces to be able to distinguish these. Such that now, when we show it an image, it can count quite quickly and effectively how many robots and how many humans there are. So we're going to get to use, so this is really machine learning in kind of action. So what I'm going to do is to offer you some challenges. So here you are. This is, okay, so you've, oh, that's it. Okay, right. I shall have to improvise. Okay. So I'm going to, that's fine, because I'll just swap over between the HDMI and that will bring you up, so that's fine. Okay, so here you are. So this is a project that was done, so I'm going to start with visual art, because vision has been the place where AI has been very successful. So you can probably recognize the artist here. This is Rembrandt, and there was a team in Holland that decided to see whether they could get their AI vision recognition to sort of understand Rembrandt's very particular style of painting. Rembrandt did quite a lot of portraits, so there was quite a bit of data, not as much data as we use to actually train our AI, but in the region of 300 portraits. And of course, one of the things Rembrandt has is a very special use of light. So it was going to learn how to put light on a portrait, a very particular style of dress at that particular time. So one of these images is a Rembrandt. The other one is the product of the artificial intelligence learning on Rembrandt's style and producing a new Rembrandt. So the challenge for you is, can you tell which of these is the real Rembrandt? Now, I'm going to just do a little experiment first of all to see whether our cards are working. So let's switch over to show you. So here you are. So I'd like you to have all put up your blue cards. Let's see whether, and you can see it's starting to pick out, some of you are a little bit edgy. I'm sorry, you'll just have to feel like your vote does count. Okay, now turn them over to red. Let's see. And you'll see the bar at the top is recording, so we'll be able to test the proportion. That's 100% red now. Turn back to blue, and you'll see the bar shoot back to the blue side. Okay, so good. So it seems to be working. So now, not to prejudice the thing, so I'm going to, let's go back. I'll just show you the pictures again. I'm going to ask you about one of these. So let me flip my coin. So I'm going to ask you about the painting on the left. I want you to vote whether you think the painting on the left is done by a AI or is it done by Rembrandt. So if you think the painting on the left is by AI, I want you to show your red faces to me. And if you think it was a human, then I want you to show your blue faces. And okay, so here we're starting to get so quite a lot of you voting red, and we're seeing, although some of you are also voting blue, so it's edging over more to red. I would say it's probably about 60-30. Okay, so good. Let's see how good you were at this one. So we'll go back to here. So which one was the AI? Yes, in fact, so you were pretty good already. So you can feel good about yourselves that as an audience, at least, you voted correctly. So yes, the one on the left is in fact the AI Rembrandt. Now it's interesting that not only did they do this as a 2D image, but if you've seen a Rembrandt, it has his use of paint is very special. It's very kind of 3D effect. And they even went to the extent of analyzing the kind of height of the paint. And so they 3D printed this, interestingly. And when they asked a Rembrandt expert to come along and review their result, and of course the Rembrandt expert was incredibly snooty and dismissive about the whole project, but the only thing that he could find to criticize it about was, well, the use of paint is 20 years earlier than the style of the actual portrait. So the team felt actually quite good that they'd managed to if that was all that was wrong with it. Okay, so, but you might say, well, what's the point about another Rembrandt? We've got wonderful Rembrandts. Why do we need any more Rembrandts? So certainly my favorite art critic, Jonathan Jones in The Guardian. I love reading Jonathan Jones because he's always totally dismissive about anything to do with AI. This is what he wrote about this Rembrandt project. What a horrible, tasteless, insensitive, and soulless travesty of all that is creative in human nature when technology is used for things it never should be used for. But frankly, anyone who wears that sort of shirt is an art critic. I'm really not quite sure I trust very much in their critique. But to a certain extent, he has a point. What is the point about creating another Rembrandt? Well, I do think there is a point, because the wonderful thing about this AI is it's starting to recognize things that we as humans have missed in the data. Not so much in Rembrandt. I haven't seen anything new insights in Rembrandt, but for example, something like Jackson Pollock, a kind of algorithmic analysis of Jackson Pollock has revealed that Pollock is doing something very special when he splatters paint around, that he's creating a very special mathematical shape that we can actually analyze and kind of judge a kind of the fractal degreeness of this dimension of these paintings. So AI is giving us new insights. There's a wonderful story I tell in the book about the Netflix algorithm that just took our likes and dislikes of films and the numbers of the films, didn't know anything about the films, but just from our likes and dislikes, was able to clump them together into films of a similar sort of genre. So you can see, oh yeah, look, these are all comedy films, these are all thrillers. But every now and again, it would clump films together because of our likes and dislikes, which is kind of expressing our common feelings for a film, in ways that we didn't really have a name for that genre. It was almost as if the AI had spotted through our likes and dislikes that there was a kind of way of clumping films together that deserved a new name. It had spotted a new sort of structure in the films that we hadn't kind of named. So I think there is a point about looking backwards. But I think the most exciting thing is looking forward. Can we get the AI to do new things, to break the mold, to do exciting new things? So here's your next challenge. 4 of these paintings are done by a human. 4 of these paintings are done by an AI. You have to now judge which is which. So we'll do the same, since I flipped, we'll do the left-hand one again. So the left-hand one is the one you're going to be voting on. Do you think the 4 paintings on the left are by the human or by the AI? So let's turn it over to you, so your chance to vote. Those 4 paintings on the left, are they, okay, so now, look, there's a Brexit vote going on there. Yeah, so you seem to be still going for it's much less convinced by that, but it's just edging a little bit over to the, yeah, it's still changing, all right. But I think you think that one's the AI one. Okay, let's go back and see, what? I think there's an Arsenal supporter over there. Red! Or something. Okay, so which one was which? No, in fact, those were 4 blue. So a few people go, yes, I knew that. Yeah, so in fact, so you found that one a bit more difficult. It's interesting because in some ways, I would say that the 4 which are produced by AI have much greater complexity to them. And these were actually shown at Basel Art Fair a couple of years ago. I think this is 2016, these were. And nobody was told there was any AI involved in this. They were just asked to give their feedback on the paintings. And the feedback on the AI ones, people were much more emotionally engaged with the AI ones than they were with the human ones. And then, of course, you see, when you then tell somebody, well, in fact, that was created by a computer, it really upsets people, I think, that, oh my gosh, but that's, there's no emotional world going on inside there. I think this is really interesting, the reaction one has to experiencing something, then finding out it's done by AI. And I think most of you, I also feel like I've been cheated somehow. But if I tell you a joke, Alain's jokes were all actually made by an AI, and you laughed at them all. But then if I tell you now, no, he actually just ran the AI joke app, does that invalidate your laughter? I don't think it does. But why I don't think we should get too threatened by this is because this AI is learning on our emotional world to produce its next step. So it's not disconnected. It has got an emotional world. It's representing our emotional world, but in a sort of new filter. What's interesting about this project, I think especially, is the way that these paintings were created. Because these 4 paintings on the right were not created by one algorithm, but 2 algorithms almost working in competition against each other. They almost made it into a game, something called a creative or generative sometimes adversarial network. So the first algorithm was tasked with creating the art. And what it did was to learn on all of the art of the past. And it became a kind of art historian. It learned how to classify art in particular styles. It understood when something was cubist art or pointillist art by doing a machine learning process on the images and being told what was in which particular style. Then it was tasked with creating something that didn't fit into any of those styles. So it was really trying to break the mold. It had to make something that couldn't be classified given the parameters that it had learnt. But it was also tasked with creating something that we as humans would recognize as art. So it had already learnt from all the art of the last 1,500 years what we regarded as art, and so it knew kind of an upper limit of how much it could push the idea. The second algorithm was tasked, it was the discriminator algorithm, was tasked with either saying, look, I think that's still stuck, you're still stuck in cubist art there, or else was saying, you've gone way too far and that isn't art at all. And it was the competition between these two that ultimately led to these images. Now, I think that's what's exciting with this particular idea, is because very often algorithms can just churn out loads of things, but the challenge is choosing which ones are interesting. So we had a second algorithm which was doing some choosing and discriminating. And this is very close, I think, to actually how humans work creatively. Here's Paul Clay talking about the act of creation. Already at the very beginning of the productive act, shortly after the initial motion to create, occurs the first counter motion, the initial movement of receptivity. This means the creator controls whether what he has produced so far is good. There's always that, you do something and then you just, is that good? I'm not sure, I'm going to throw it away. I'll do something again. Here's Paul Valéry, a French poet, talking about the idea of these two kind of mindsets. It takes two to invent anything. The one makes up combinations, the other one chooses. And I certainly find that as a mathematician, that I have collaborators around the world where we kind of play these two roles. So I have a collaborator in Germany where I'm the kind of mad creator and he's the discriminator, kind of knocking things down, whilst a collaborator in the Middle East that I have, he's the kind of mad creator and I'm the discriminator in that case. And it's by doing that kind of combination that we actually make progress together. Okay, so we've done the visual world. What about the written word? The written word, we already heard how text kind of prediction produces some strange effects. The written word, interestingly, AI is having quite a lot of difficulty with. But then again, it's one of the first things that AI was actually interested in trying to do. This is the Manchester Universal Computer. After Turing left Bletchley Park, he went up to try and realize some of his ideas in Manchester. And the team there were rather perplexed when letters started appearing around the lab, which were kind of love letters written by the Manchester Universal Computer. And they were sort of a bit perplexed by this until one of the team admitted that in fact he'd written a program for the computer, which was a template, and he was using a random number generator that Turing had just created for the computer, which was randomly filling in the template with words, amorous words. So after a while, you'd spot the template, so not very good. But poetry is somewhere where AI has been quite successful. I think partly because it's, again, nice closed form. It's not asking sort of too much large-scale structure. Also, I think that art actually, as an audience, you bring a lot of your own creativity when you look at a piece of art, don't you? I mean, I think that's the point. An artist leaves room for your own world to fill things with. There's an ambiguity to things. And so, poetry has a slight gnomic quality that I think especially is something that you bring a lot of your creativity to when you read it. So here are your challenges now. I've got some poems for you. I want you to vote whether you think these poems are, gosh, this guy's already gone, no, got poetry now. So whether these poems are by AI or are they by humans? So bot or not, okay? So here's your first poem. So I'll read you the poem and then we'll go to see what you think about it. I won't read it all. So, mortal my mate, bearing my rocker heart, warm beat with cold beat company. Shall I earlier or you fail at our force, and lie the ruins of rifles, once a world of art? Okay, let's stop there. So do you think that is bot or not? So now you're just voting red for robots, blue for... Oh gosh, I didn't get that one positive. Okay, so as a massive vote for red there, a few thinking it's human and blue. Okay, so that was your first challenge. So let's go back to your next challenge. I won't reveal them yet, okay? I've got 3 poems for you. Okay, so here's your next one. This is quite different even to read. There are smallnesses of plasticide reaction of real time, of packs of displaced exclusionary heart, hurt, of powerlessness of magazine fired non-dignified, as het fatty implied, internalized violence of frozen helplessness is off-white cholula. Okay, so what do you think? Do you think that is AI or do you think that's human? Okay, so let's over to you to vote. Am I messing with you? Or, it's clearly, okay, so you think, that's, so that's quite a little vote for human there, but still some people thinking, okay, is this a double bluff? Because that's clearly code. Okay, so I think you've gone for human there. Okay, so, right, this is working okay. So here's your next challenge, bot or not. Imagine now the dark smoke, awakened to fly all these years to another day. Notions of tangled trees, the other side of water. I see it is already here. Sequences of her face, see it as shared and old friends pass their dreams. Bot or not? Okay, so over to you. You think they're all bot? Okay, so you're going for bot on that one. So that's right. So you think they're all AI? That's the sort of thing I would do, isn't it? Okay, so let's see. So you've gone for the bot on that one. Say again. There you went to human. Yes, that's right. Sorry, you're absolutely right. Yeah. Thank you for picking that one up. Yeah. So let's go back. Let me give you the answers then. So the first one, you were all pretty convinced that was AI. Poor old Gerald Manley Hopkins will be turning in his grave. What? You think I'm from... I chose Gerald Manley Hopkins because I've never understood any poem that Gerald Manley Hopkins has ever written. So didn't sniff that one out. Second one, yes, you did sniff out that, okay, that's too much like code. It can't be an AI. It's actually a young Australian poet called Mez Breeze, and she's very interested in this kind of interplay between computer code having its own kind of poetry and rhythm to it, yet having meaning that might have something to say to us. And so she's very interested in this kind of weird interface between the two. So actually we've had two humans, so that leaves the last one. Is that human? Did I really mess with you? No, the last one you sniffed out, actually, was the only one that made any sense at all, was in fact the only one created by an AI. This is actually, Ray Kurzweil created something called the cybernetic poet. And this is a machine learning process where he took poems of Yeats, Keats, Eliot, and then the bot was kind of tasked with creating something which was a kind of fusion of Yeats and Eliot, for example. So, of course, Ray Kurzweil is one of the people who are talking about the idea of the singularity, the moment when computers might actually be more intelligent than humans, and so that moment, the singularity. So poetry actually is not doing too bad. It's a kind of longer scale writing that AI is having real difficulty at. So it can generate quite interesting sort of text generation on sort of small scale, but it's kind of the idea of writing a novel is still way beyond it. Although there have been some attempts to write novels. So there was a very interesting case by a team called Botnik. They decided, they're big Harry Potter fans, and they decided they were very disappointed there were only 7 volumes of Harry Potter, and they wanted an 8th. They wanted to know what happens next. So what they did was they got the machine learning to take all of J.K. Rowling's writing, learnt kind of ideas that she's interested in, her style of writing, and decided they would create an algorithm to create an 8th book. So here is the beginning of this 8th book. I actually love the title. This is called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. I'd read that. So it starts off pretty well. Magic. It was something that Harry Potter thought was very good. So good, it's already picked up that these books are about magic. Yeah, not bad. Leathery sheets of rain lashed at Harry's ghost as he walked. Leathery sheets of rain, I think that's a beautiful image. Leathery sheets of rain. As he walked across the grounds towards the castle. After this, it began to lose the plot a little bit. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Well, that much good. Ron's Ron shirt was just as bad as Ron himself. So AI is it's very good at kind of local generation of things which have some sort of meaning, but it doesn't have a very good sense of a long-term structure. Okay, what about music? Lovelace, Ada gave us this challenge of whether AI could produce music. And music is full of lots of patterns. A composer, when you hear a piece of music on the radio, you can probably very quickly pick out what the composer is because they have particular styles, particular sort of sound world that they have. Can the AI learn that and be able to produce something at a particularly good level to replicate or do something new? So AI always starts on Bach. Bach is where AI always starts because Bach has a lot of algorithms at work. If you do look at something like the musical offerings, Bach wrote the musical offerings, these little pieces he wrote for Duke Ferdinand, as a kind of puzzle to solve. There was a little algorithm you had to show, which you had to expand and see what the music actually meant. So actually Bach is a very good place actually for AI to start. And some of you may remember a few weeks ago the Google Doodle. Did you ever go on the Google Doodle? It was celebrating Bach's birthday. And this Google Doodle, you could put in a line of music and then it would harmonize the other 3 voices. So the machine learning, this is based on something called Magenta. It had taken all the chorales that Bach had written. Chorales are very good because they don't change key very often. They're very sort of boring. But it can learn a lot about the way that a chorale, and a chorale is filling in the harmony is a bit like filling in a Sudoku. You've got to just learn the rules. So this would actually, the little Google Doodle would fill in with your tune. So I actually put in a bit of the musical offerings. So this is my attempt on it. Because the musical offerings is actually quite a difficult challenge. It doesn't seem to have any key to it at all. And when I played it back, it was really rubbish, actually. But what was very nice about the Google Doodle is that you could then say, I thought that was rubbish. And the thing would learn and actually say, okay, that harmonizing didn't work. And so you were training the algorithm as you gave your feedback. And if you thought it was good, it would kind of reparameterize and say, okay, I'll do more of that sort of harmony. So very nice. So what we've done, I've got I actually set up a centre in the Royal Northern College of Music with a composer, Emily Howard. It's called PRISM, which stands for Practice and Research in Science and Music. And what we're really interested in is this kind of interplay between the scientific and mathematical world and the world of composition. So we've done various projects. We wrote a string quartet representing mathematical proofs together. But I've now got a PhD student who's a composer, which is really exciting. Rob Laidlow, he actually had his quartet premiered last week at the Wigmore Hall. He was going to be here tonight, but unfortunately he's ill, which is a real shame. But he's been working alongside me and various other people actually here in the university as well to produce a piece using some of the best software we have around at the moment to create a kind of hybrid AI Bach piece. And this is what we want to play you. So the challenge here is, so we've got a fantastic musicians in the department here, and Kobe is going to come up and play this piece for you, which is, we've just been doing very straight AI human tests. This is a slightly different challenge. You've now got a piece which sometimes is AI and sometimes is Bach. And I'm not going to tell you how many times it moves between one and the other. And what I want you to do is to see whether you can see where the joins are. Can you tell, oh gosh, no, that's horrible. That's gone AI, or, oh yeah, that's Bach. So we're going to run this twice. The piece is about 4 minutes long. So we're going to record your thoughts on this, and then hopefully if we can do this, I'm going to play this back to you. Oh gosh, because now we don't have two screens. That's going to be quite tricky. Okay, no, I know what I can do. Okay, yeah, I've thought of an improvised way of doing this. I'm going to do it very analog. So you'll see what my solution in a minute. But okay, so perhaps we can give a big round of applause to Kobe, who's going to come and play this piece. We have a page turner as well. And so just to set this thing off, can you all show your blue faces? So we're going to just start you off all on blue. So the idea is, as soon as you think that the music has gone into something which is not by Bach, you turn to the red face. And if you think it's gone back to Bach, you move to the blue face. Okay? It's very simple. Okay, so now in order to sync these things, I'm going to have to count this down. So hopefully we can show these two things again. So you ready? Ready, Kobe? Okay, so I'll go 4, 3, 2, 1. No, it was very interesting. I think there are moments when Bach will be turning in his grave, as you'll see. But it's interesting because I think when it was Bach, there was much more confidence in your knowledge of that. You could feel it was right. But when it wasn't, it was really kind of edgy. And there were moments when it suddenly surged red, which there were giveaway moments. So, we're going to replay this so you can actually see what your answers were. This was actually, so what we did was we took one of the English suites, so this is the fourth English suite, and what we did was to take these bits out of the piece of music and then ask the AI to fill in the gaps. And the machine learning it's interesting because we actually use quite a simple piece of machine learning. It's called Clara. It's developed now. It's developed by OpenAI, this team which is trying to make AI very open to the world, something that Elon Musk has helped set up. So this is actually by a piece of software written by Christine Payne as part of the OpenAI project, and it's growing. So we're going to keep on working on this to make it even better with something called MuseNet. But what's interesting is that this is kind of predictive in the sense of it hears what's happened up to date and then makes a decision about what will be next. So some of the AI is working very cleverly and working backwards as well. So knowing where the piece is going, it can make some prediction. But this piece of software does not have a long-term memory. And this is one of the challenges, to create a piece of music software that can actually know about what it's done in the past and exploit that in its decisions as it goes forward. One of the things I talked about with Kobe beforehand, he could feel the AI very clearly because the AI is not embodied. So it has no trouble with giving really awkward fingerings, whilst Bach was writing something that would fit very nicely under the fingers. So I think this is one of the challenges of AI very generally, is the idea of it not being embodied. And you could really feel that it just did. I mean, when I first played through it, it was just like, whoa, this is just really gooey. Okay, so let's play that back. So what I was hoping to do is have things on one screen and the other, but I think what I will do, so we're going to play, yeah, exactly. So let's, we'll get the thing up here. So we're going to get, poor old Kobe's got to play this again. The bits, the Bach is great fun. And what I will do analog-wise, so I was going to do this on the screen, but I will just show you as we're going along which bits are AI and which are not. And so you'll be able to see what you voted, and I'll tell you what the answers are. Okay? Analog, that's all right. Okay, so actually I sort of slightly bias things by asking you to put all up the human face, and I wanted to see how long it would take until you actually spotted that the opening wasn't Bach at all. It was, in fact, so it took quite a long time. So we're going to start, so we're going to count this down so we get the syncing right, hopefully. So they all are ready. So 4, 3, 2, 1. You pick that up quite quickly, that was Bach, I think. You can hear that it's got some sort of direction to it. Poor old Bach. Oh dear. Now you can feel it's gone Bach. Great. And thank you very much, Jacoby. Now, one of the things I was very strict about with Rob, the composer, was that it had to be AI. He was not allowed any chance to try and improve the AI. So we were very strict about, because very often when you look at projects, and many in the book, although it's saying it's an involvement of AI, you can see there's a lot of human input, because it makes a much better story if you just say it's the AI and the human isn't involved at all. So I was very strict with this, that the portions that were AI had to be only AI. And interestingly, we asked it just to fill in the last chord, and it missed out one crucial note, which made the whole thing resolve. So, but you can see from that actually it was pretty convincing, and there were a few giveaway moments, but actually quite hard to pick out which was the AI. I think you were pretty good on what was Bach, although there were a few horrific moments when you thought it was AI, and Bach will be poor turning in his grave. So I think that, again, what's the point of this? Well, I think there is a point for creative artists, and I think this is not about competition, this is about collaboration. This is a new tool to push our own human creativity. We've already seen that in the realm of art, but in music, one of the most interesting stories I saw was the idea of an AI that had been trained to play jazz. It's called the Jazz Continuator, something constructed in Sony Labs in Paris by François Pachet and his team. And they got the AI to learn in a very similar way to a jazz musician, learning what the probability is of the kind of next move after a certain sequence of notes. They then did a concert where people found it very difficult to tell when it was the human playing or when it was the AI. But what struck me was the jazz musician who had this AI been trained on, his response to hearing the AI play back to him. And he said, this is Bernard Lubat, the system shows me ideas I could have developed, but that would have taken me years to actually develop. It is years ahead of me, yet everything it plays is unquestionably me. And I think this is what's exciting, because I think that we as humans often end up behaving very much like machines. We get stuck in our ways of thinking. We just perform the same ideas over and over again, especially in creativity. I know that in my own mathematics. I try the same things over and over again. And sometimes I need something to push me out of the way I've been thinking and see that my world of possibilities is much richer. It was like Bernard Lubat was in a room, the spotlight was on him. He didn't realize there was so much more to play within his sound world. So the exciting thing for me is that this movement into an AI that might be creative, it's not about a threat, it's about an opportunity. It's about the fact that this thing could push us to behave less like machines and actually become more creative again as humans. Thank you.